everyone. My name is Jasmine Gratton. I'm a final year PhD student at UCL at the Institute of Cardiovascular Science in Professor Arun Hingorani's group. And today I'll present to you one of my projects entitled Modeling a Two-Stage Screen for Autosomal Dominant Familial Hypercholesterolemia, also known as FH. So autosomal dominant familial hypercholesterolemia, or FH, is an inherited condition that's caused by deleterious variants in the LDLR, ApoB, ApoE, or PCSK9 genes. And the gene products are involved in the cellular uptake of circulating LDL cholesterol from the blood, as you can see in the figure. And so FH is characterized by elevated LDL cholesterol concentration, and this burden leads to premature coronary heart disease and death. There's currently no cure for FH, but treatments include lipid-lowering therapies, such as statins, and these have been shown to be highly beneficial in FH patients. So the estimated population prevalence of FH is about 1 in 250 to 1 in 300 individuals, making it the most common monogenic disorder in the world. However, it's still highly underdiagnosed, and it's estimated that only about 7% of UK FH patients have been diagnosed. So the main reason why FH is highly underdiagnosed is because there's no systematic way of identifying new FH cases in the population. So there's no population screening strategy in place for FH in the UK. If we use LDL cholesterol concentration as a screen to identify monogenic FH cases, this is cheap, but it's also highly inaccurate because other factors influence LDL cholesterol levels throughout a person's lifetime. If we use genetic sequencing of FH variants as a screen for FH, this is highly accurate, but it's also very expensive to do as a population-wide screening strategy. So current case detection is done in an opportunistic way, and new patients are diagnosed in the clinic using clinical criteria such as the Simon-Broom and the Dutch Lipid Clinical Network. And once a new FH patient has been diagnosed, cascade testing has been shown to be highly time and cost effective. And so this is illustrated in the figure. And cascade testing involves mutation detection of in close relatives of index FH cases. And once an FH variant is identified, treatment and cascade testing of the next generation of individuals is initiated, and so on. So the challenge here is to identify new index FH cases that would seed this cascade testing program that's already in place. So while there is currently no population screening strategy in place for FH, in 2007, Wald and colleagues published a child-parent screening strategy for FH. And this involved measuring children's total or LDL cholesterol concentrations at 15 months of age during routine immunization. And LDL, as I mentioned, LDL cholesterol concentration is not very accurate in detecting monogenic FH cases in adults, but it's actually quite accurate in children because lifestyle factors have not had as much of an influence on their cholesterol levels. So this child-parent screening strategy was, so it's illustrated on the figure, and it involves measuring children's total or LDL cholesterol levels, and children with those levels exceeding a certain pre-specified threshold value would then optionally be sent for DNA sequencing to test for an FH variant. And their parents' lipid levels would also be measured, and the parent with the highest lipid levels would be considered an FH case, and then cascade screening would be initiated in close relatives of the family. This strategy was also validated by Fatima et al. In the ASPEC study, but it's not currently recommended by the UK National Screening Committee. So this work led us to hypothesize that a two-stage screen for FH could work in adults, which we have modeled in the UK Biobank. And the idea behind this is that the NHS in the UK offers free vascular health checks to adults aged 40 or above, and their lipid levels are measured during these health checks. So this would provide an ideal opportunity to implement FH screening in the general UK population. And this two-stage adult reflex screen for FH involves a first stage where individuals' LDL cholesterol concentrations are measured, and those with levels that exceed a pre-specified threshold value would then be considered to be potential FH cases. And as I mentioned before, this stage is not very accurate at detecting monogenic FH, but it is cheap. So it also yields a high number of false positive cases. And then stage 2 would consist of a genetic sequencing step, which is limited to individuals whose LDL cholesterol concentration exceed the threshold value in stage 1. And this is to either confirm or refute the presence of an FH variant. And so this second step of genetic sequencing is very accurate in excluding the false positive cases from cascade testing. And individuals who are found to have an FH-causing variant after stage 2, so these are the true positive cases, they would then be the new index cases that would see the cascade testing program, which is already in place. So we modeled this two-stage adult reflex screening study using the UK Biobank data because it provides LDL cholesterol concentration and exome sequencing data that was necessary to ascertain FH status. And so out of 100,000 so unrelated white British participants, we identified 488 individuals with a pathogenic variant for FH. And this was done using the exome sequencing data from the LDLR, ApoB, ApoE, and PCSK9 genes. So this equates to a prevalence of around 1 in 288 individuals, which is similar to the estimated population prevalence of FH, which is estimated to be between 1 in 250 to 1 in 300 individuals. So the two main aims of our study were first to model this two-stage adult screening strategy using various LDL cholesterol threshold values in stage 1, and then compare the results to the child-parent screen published by Wald et al. So these are the results that we obtained after modeling this two-stage screen in the UK Biobank for various LDL cholesterol cutoff values. So we've converted the numbers obtained for 100,000 individuals screened, which is shown in this figure. So here I've highlighted the various LDL cholesterol threshold values that we tested. And these are the number of individuals whose LDL cholesterol concentration exceed the pre-specified threshold values in each of the rows. And these are the individuals that would then be sent for exome sequencing in stage 2. And here, these are the total number of FH cases detected for each of these LDL cholesterol threshold values. And I just want to point out that the x-axes are not on the same scale. So this orange vertical line represents the 347 FH cases for 100,000 individuals screened. So you can also visualize the number of FH cases that would be missed by each of these LDL cholesterol thresholds. So as you can see, the lower the LDL cholesterol threshold value applied, the more individuals are sent for sequencing in stage 2 due to a higher number of false positive cases detected. But we also detect more FH cases, and equally less FH cases are missed. And now if we have a look at the LDL cholesterol threshold value of 4.8 millimoles per liter, we get the detection rate, or the sensitivity that we obtain, is almost equal to 40% for a false positive rate of around 10%. And at the moment, only around 7% of UK FH cases have been diagnosed. So this would be a vast improvement to the current situation. And now if we compare the adult reflex screening strategy to the child-parent screen published by Wald et al., we can see that there are some differences. So first of all, in the child-parent screening strategy, this involves screening children, while the adult reflex screening strategy involves screening adults. The biomarkers evaluated and their cutoff values are also slightly different. However, for these thresholds and biomarkers, we can see that twice as many individuals exceed the biomarker value and are sent for sequencing using the adult reflex screen. This means that a lot more false positive cases are obtained in the adult reflex screen compared to the child-parent screening strategy. And less FH cases are also detected using the adult reflex screen. And additionally, if we have a look at cascade testing of these newly identified FH index cases, we can see that the child-parent screening strategy identifies an additional generation of individuals compared to the adult reflex screen. And this is assuming that the parents of the adults screened in the adult reflex screening strategy are either deceased or too old to benefit from lipid-lowering treatment. So this means that for 100,000 individuals screened, the child-parent screen followed by cascade testing identifies 1,061 FH cases, while the adult reflex screen identifies 345 FH cases. So while this difference might seem very large, we must remember that currently there's no population screening strategy in place for FH, so the adult reflex screen is still better than the current situation. So in conclusion, FH is highly underdiagnosed, which is a missed primary prevention opportunity, and this has been identified as one of the NHS's long-term plan goals. So there is a need to implement a population screening strategy for FH, and we have here developed and proposed an adult reflex screen for FH, and if implemented, this would help identify around 345 new FH cases for 100,000 individuals screened, if followed by cascade testing. And we've also shown that this method is not as efficient as the child-parent screen, but it has the advantage that it can be implemented into the NHS health checks, and it does also overcome the obstacles of having to screen children. So I'd like to finish off by acknowledging my supervisors and collaborators, and also the organizers for inviting me to speak. And happy to take questions.